Welcome to the Alabama 2021 Remote Envirothon Training. My name is Dale Dickens. I am your Urban Forestry Coordinator with the state of Alabama. I work for the Alabama Forestry Commission. We'll be going through about 30 minutes of material. Please understand there's a lot more to that. In the handout that should accompany this video, there not only are tree values, but there are a couple of links for other Envirothon learning material. Please look at those before you take the forestry exam. All right, we'll get started here. The Alabama Forestry Commission that I work for that is your state forestry agency. On the screen is a picture of our website, and we are legislated to protect, manage, and educate about the state's forests. So you may want to just type in forestry in Alabama and take a look at our website as well. As the urban forester, I especially like you maybe take a look at some of the managing the urban forestry. I also handle the champion trees, which is the largest trees in the state of any given species, and you may be interested in that. Now, in Alabama, well, really nationally, there's some confusion about the Alabama Forestry Commission, which is your state entity, and the USDA Forest Service, which is the national entity that looks after, as it says in the slide, they are responsible for managing the 191 million acres, from shore to shore in Alaska and Hawaii. Most of their land, 191 million acres, is in the western United States. And the Forest Service, although they have a large chunk of the federal land, it's only about a third of the 770 million acres that nationally they look after. If you've been to the Talladega National Forest that you see in the image, or Tuskegee National Forest, then that is the USDA Forest Service, not the Forestry Commission. Sometimes we're also confused with the AFA, which is the Alabama Forestry Association, and that is a lobbying promotional vehicle for the forestry landowners and industry inside the state. That said, this is the forestry module, so we need to know what is forestry. The Society of American Foresters, which is our national society, their dictionary defines forestry as it's the profession embracing the science, art, and practice of creating, managing, using, and conserving forests and associated resources for human benefit and in a sustainable manner to meet desired goals, needs, and values. And pay particular attention to that word sustainable, which means that however we leave the forest, they should be just as valuable, just as aesthetically pleasing, if not more so than when we leave it to future generations as the way we received it. So that's forestry, and we said that's managing the forest. So what are some of the general forestry facts in the state? Well, timberland, commercial timberland, continues to increase in Alabama. We're at 23.1 million acres. The Forest Inventory Analysis Group here with the Alabama Forestry Commission, they look at the land and take plots every year, and every 5 years they put out a report. That 23.1 million acres is 69, more than 2/3 of the state. So we are blessed with a lot of natural resources and national areas. But not only are they beautiful, but it's forests, commercial forests are the #1 asset producing industry in Alabama, which means that real value, real wealth and money for the state of Alabama. There's not an industry that does more than the forest industry. Unlike the Western United States, which a great portion of that is federally owned, Alabama has only 5% publicly owned lands, forest lands. So private owners, both corporate and individual loan owners, non-private, private, commercial forestry interests um, own a large portion of it. We are still growing timber faster than we're harvesting it, and we plant roughly about 215,000 acres annually. And that's how you keep your forest growing, even though we're harvesting a tremendous amount of wood. Um, and of course, that's just what we planted. There's also natural regeneration going on from seed. It's either blown in or blown, applied, or um, from sprouting. In Alabama, we've got 6 general forestry types. At the bottom, you'll see longleaf and slash pine, the longer needled. The majority of the state is in loblolly. Um, as you get into the tail end of the Appalachian Mountains up north, you'll start seeing oak and pine, some oak hickory in the extreme north, in the Huntsville and Florence areas, and scattered about, particularly in the wetlands, you'll see oak gum. And of course, as the urban forester, we have areas when you see the pink, and that's probably growing. We'll talk some about urban sprawl, but there is more and more development going on, taking some of the trees out, areas out of tree production. All right, first key point, tree physiology. How do trees grow? What do we need to know about those? Again, each of these key points, I wish I had, an hour or a day to talk about. Understand there's a tremendous amount to it, much more than what we're covering. Um, if you would like a forestry or wildlife degree, you go to one of our 4-year universities, and that's what it takes is 4 years. So understand we're going to be going through this very quickly. But we're talking generally about the tree needs, physiology parts, and photosynthesis. Before I go to the next slide, I want you to stop and think, all right, from all of my science classes, what is it that trees actually need? What are the necessities of life for a tree that's growing out there? For one thing, they have to have sugars. They have to have energy, and they'll get this. We'll talk a little bit more about photosynthesis, but you got to have energy. For the metabolic activities, to get that sugar where it needs to go and to grow, you need water. And that's probably the number one limiting thing. Even in Alabama, with our 60 inches of rainfall every year, water is what they're competing for, first of all. And then the next thing would be light. But with that water, we also are hoping that they're taking up nutrients, different things, NP and K, nitrogen, phosphorus, potassium. And then there are micro elements that the trees also need. There are different hormones and enzymes inside of the tree. Some they can take up, but the majority they have to use energy to construct these larger molecules. So we want to preserve those as much as possible. On the helpful side, you'll learn that the number one killer of trees is fungi in the form of disease, but they're also beneficial fungi that help the tree. And one of them is the mycorrhiza. You notice that's a difficult word to spell, mycorrhizae, mycorrhiza. And those are small fungi. You can see them with the naked eye. They'll attach to the roots. They grow in the soil. And it is a mutually beneficial situation where while the fungi may pull some water and nutrients out of the root from the tree, most of the time it's pulling in a lot more. It gives the tree a much finer root system. And you think of it as an add-on. It's an app for the roots to pull in more water and nutrients. And of course, there's a lot of other environmental factors. I think I already mentioned light. They compete for light very heavily, but both biotic and abiotic. Biotic is things that are living, and abiotic are things that are not. Abiotic would be soil compaction that affect. They have to have soil structure to hold up the tree. Abiotic, again, the mycorrhiza will be an example of that. So those are necessities of life. The tree parts, of course, you have the crown up with the leaves and the limbs. They're held up by the trunk, and then you go down into the root system. Uh, but if you saw through the tree, you see how trees live. The live part of the tree, if you'll see in the top of the slide where it says cambium, that's really the only living, changing, growing part of that stem. In the interior, where you see heartwood and pith, most of that material is dead. It looks like lumber because that's where lumber comes from. Um, but in that cambium, you have the protective bark on the outside, and then you have the phloem, which is growing out. They're phloem and xylem side by side, forming up that cambium. And on the outside, toward the bark of the tree, the phloem is taking the sugars and waters, the things that the leaves are producing, and feeding the roots. It's going down. The xylem, those long, thin cells, are taking the water and making sure it goes up into the tree, um, so that the leaves have the water they need. You'll see that's an important part of photosynthesis. So xylem, these small, think of them as tiny pipes, tiny tubes, and they're really, really small, smaller than human hair. But inside there's tremendous pressure because you think about it, it has to pump hundreds of gallons of water sometime up, you know, 40, 50, 100 feet up to where the leaves are. So there's a tremendous amount of pressure in there. So phloem and xylem are a very important part of the tree. And I'll mention here, you'll see in the temperate season with a lot of our species, we have summer wood and spring wood. And you can count those. We have those every year. Unlike the rainforest, you can't do this in the rainforest. But we have summer and winter. And so in the springtime, there's a lot of water, a lot of nutrients. The weather temperature is um, nice for trees. So they don't put a lot of effort into protecting the water. They're growing as fast as they can. And then the summer hits, water is a little harder to find, and you start seeing thicker walls. So that thicker walls makes the wood look darker. So in this tree, we can go from the pith in the center, and that's just a little quirky. That's wherever you are on the tree, the center, that pith is that first year growth, which is not very strong, but you can find it. Um, and then you can count the rings out. Now, one mistake people will make is if you look at the rings of a tree, and what we're looking at here, let's say it was where we often measure is 4.5 feet off the ground, and we count 14 rings. Does that mean the tree is 14 years old? Well, no, it didn't just that first year shoot up 4.5 feet. It may have taken it a year or two, so you always have to add that extra year. But that's some of the quick basics about tree physiology. Again, that's a full college course and a biology course. So make sure you look at some of the reading to understand that you know more. But one of the most important things we have is photosynthesis. And if you don't remember your biology, photosynthesis is the way plants will take inside the leaves, is where this occurs. The, the trees take sunlight, that energy, and using carbon dioxide and water, they convert it into usable fuel. You remember ATP, adenosine triphosphate? That's the one that carries the energy back and forth within the cell. And on the lower left of your screen, you should see the formula. That's a basic formula for photosynthesis. The H2O is water, the CO2 is carbon dioxide, and the tree, the dotted line is the photosynthesis, and it's producing C6H12O6. What do you think that is? Remember, they're producing sugars. So that's the sugar, and it releases oxygen for us to breathe. Releases oxygen for us to breathe. I was getting ahead of myself, but One of the questions I often ask um, is, do trees use oxygen? And some of the younger students will blurt out and say, no, they produce oxygen. And that's true. They do produce oxygen through photosynthesis. But everything that's alive respires, that's the word. And that is, they need oxygen. That's why when beaver builds a dam and floods the, the roots of some trees, if they don't have a means to survive that flooding, they'll die because the roots need oxygen to survive. Um, so there's our CO2 on the right, and oxygen. It's making sugar and needs that water. And forgive me, but that's C55H72O5N4 and magnesium. And the last part of magnesium, Mg is covered up. Does anybody know what that is? That is the formula for chlorophyll. None of this works without chlorophyll in the chloroplasts in the leaves. They're the receivers of that solar energy. And of course, you need Mr. Sun. You need both of those things. So we have the leaves and they're pumping away and they're keeping our tree alive. What happens in the fall with deciduous trees? Deciduous trees drop their leaves in the fall. Conifers, our loblolly pine is an evergreen, that they do shed their needles, their leaves, just like the hardwoods do, but they do it periodically throughout the year. They don't drop all of them at one time. So those are deciduous hardwoods. Um, Here's an interesting question for you. Why do the leaves change color in the autumn, in the fall time? Football season rolls around and you'll see a lot of reds and yellows and oranges. Um, is that pumped into there, or how does that work? The truth of the matter is, those compounds, trees always have leaves with reds and yellows and oranges in them. But as the fall comes on and the days get shorter, the chlorophyll production is less efficient. And that chlorophyll, as you saw, is a big molecule. It's expensive for the tree to make. So it will pull that chlorophyll back into the stem to use when the days get longer and it's a little warmer. Um, and it leaves some of the red compounds, those chemicals, those anthocyanins, and some of the yellows, the carotenoids, yellow or orange, and they become the dominant pigments in the leaf, and then eventually the leaves drop off. All right, that brings us to key point 2. We're going to talk about forest ecology and health, forest structure, concepts, biotic and abiotic factors. Forest structure for most of the times when a forester is looking at that, I'm looking at the forest structure and I'm saying, what does it generally look like? How tall are the trees? How are they dispersed? Um, the definition itself, horizontal, left, right, vertical, up and down distribution of components of a stand. And we're looking at the height of the trees, given their age, the diameter of the trees, how many crown layers are there, or is it mixed? The number of stems, shrubs, herbaceous. What does it look like in there? And one way we will classify that as we're measuring it, we'll see, do we have a good dispersion of dominance and codominance? Do we have too many suppressed trees? The superior economic products, are they being suppressed and not growing very well? So if you'll look at this diagram, anything beneath the silhouettes of the trees, if it has a D, it's a dominant. That means that it has full sun above and on most sides. It's the big daddy of the forest. They've done really well. But there are probably most of the trees are codominant, which means they have sunlight overhead and they're still competing and growing pretty well, but they're blocked on their sides by their brother codominants, or they've got a dominant nearby. So they're not the big daddies, they're like second place. And then there are trees that we're not sure about. They're sitting and waiting. They have a little bit of sunlight coming from the top, but they really don't have a lot of direct sunlight. They either are fixing to fall out of the stand, or if lightning or beetles take out one of those codominants, they're poised to raise up and become a codominant. And then finally, we have those that are not doing very well. They're suppressed. They're underneath the canopy. Now, there are some species like dogwood that are understory species. They won't like the shade. They need the shade. Um, but in this case, we're really talking about trees that have not competed well for one reason or another. Um, and they're underneath the other trees. They are using water and nutrients. And if you're trying to maximize wood growth, you may want to get those, find a way to get those removed. Again, structure, we're looking at it, not just the individual trees, dominant, codominant, intermediate, and suppressed. But if we are managing a forest and we are managing different blocks of land the same way, clear cut and replant, or coppice regeneration, we'll talk about in just a second. It looks like what you're seeing on your left. All the trees are basically the same age. Now, in this diagram, they're also roughly the same height, and that may or may not be the case with the same age. Some trees don't grow as fast as others do, but typically they'll look like this on the left. Uneven aged, we allow the trees in the forest to grow more naturally. You're having fires and beetles open up spots, so you have younger trees, shorter trees in there. If you're harvesting in there, you're probably using selection, so you're taking out a tree here and there. You're not doing it across the entire acreage, so they don't look all the same height or the same age. So even age management and uneven age management. Well, it affects how you will actually, what you do out there, how you manage that forest. And one of the things you should be aware of is secondary succession. Even if we do nothing, um, it's a slow process. But if we have a catastrophic fire, we're not talking about prescribed fire where we burn on the best days to have a low flame that goes through. You'll see that's one of our treatments. But a catastrophic fire, like they're having out west, and it burns everything down. Everything is dead. It almost sterilizes the soil. On those, it may take a number of years for the first forbs, grasses, to start out. A lot of them are annual plants from seed that's blown in. They pop up, put out their own seed, and then they wither away. And slowly but surely, you'll start getting more grasses and perennials, plants that last more than a year. Then shrubs, the grasses get a little thicker. You'll start off very often with pines. I remember taking a trip with my wife down to the Sugar Bowl in 1983. And that was one of the first lessons I taught her. I said, if you look at our pine plantations, y'all can do the same thing if you're coming down 65, or traveling 65 between Mobile and Montgomery, I-65. Some of the plantations that you see, if you'll look beneath them, you'll see sweet gum and different hardwoods coming out. So first the pines and then the hardwoods, because many of our forests, the climax species, climax meaning the end, what that tends to be fairly stable, are hardwoods rather than pines. Pines and sweet gum and willow are mostly what we call pioneer species. They like to come in where there's a lot of full sunlight and there's not as much competition from other species, not as much shade. So that's succession. All right, forest health. Forest health, if you remember, protecting is one of the things the Forestry Commission does. And wildfire fighting, when most people see our trucks, and it has the decal on there that we're, firefighter, fire response team. We're fighting fire. We're talking about insects, disease, and more. There are other health issues that we work on. I think it's important with forest health, or what I'd like all you students to understand, is that trees don't work like people do. If you came and looked at my knees, if the best doctor in the world looked at my knees, he most likely could never tell that at one time I skinned my knees right riding my bike, fell off my bike, because those cells have been replaced over the year. You won't be able to tell. But trees don't heal, they seal. They cover over their injuries. So if you saw into the stem, when you're making lumber, you can see every little bump, tear. So when you take an axe and whack a pine tree on the national forest, um, you've damaged that tree for its lifetime until it passes away. But trees usually don't die from small injuries. God designed them very well to handle insects and fire and those other injuries. It gives protective bark. But when it is injured, it tends to seal over. And Dr. Shigo came up with an acronym, which is CODIT. It's compartmentalization of disease in trees. And he worked and studied, and actually trees, depending on where the injury is, they have 4 different walls. They try and wall off the injury because the number one killer of trees uh, is disease. Second, if at all, second only to development. But in Alabama, I'm thinking disease is probably it. So code it, remember that, and the 4 walls, and how trees seal off their injuries. They don't heal. So what other diseases is a biggie? But insects, what you see in the slide is a non-native invasive insect that was introduced into Alabama. It's in Calhoun County now. And I used to say it kills all your ash trees. And they got the data in last year from Michigan where all this started. And it didn't kill all the ash trees in Michigan where it started. It only killed 99.98% of the ash trees. But it's pretty close to all of them. In Alabama, it's not moving as fast as it did in Ohio and Michigan. It's moving pretty quickly out in Colorado. Most of these places, this insect it doesn't fly. It didn't fly from Ohio and Michigan out to Colorado. It was flown or driven. So please don't carry your firewood around. Forest health, insects, talk about urban sprawl. We're cutting down trees to put up malls and box stores. And hey, I shop there too and understand that's what we want. They're not a bad thing, but we need to be a little smarter about where we put them and how often we put them and whether we should put some trees and some green space around them. That's what we'd like to see. And that would help us with biodiversity, trying to plant different trees. My old uh, partner, Will Liner, always liked to talk about the 30-20-10 rule. And if you remember in your tree identification or your biology class, when you have family and genus and species that help identify individual trees and plants and animals, the 30-20-10 rule is when you're planting a large area, a city or a forest, you don't want more than 30% in any given family, 20% in any given genus, and 10% in any species. And different people argue different things, but most of them agree that we need some diversity because when you have a monoculture, all one species, when a non-native invasive like this comes in, it kills a majority of them quickly, and that causes a lot of problems environmentally for us. Forest fragmentation is the breaking up of our forest. We used to have large spaces, and we still do in areas of forest. Um, the neotropical migratory songbirds need large areas of undifferentiated forest to survive. Um, Air pollution, climate change, all these things are issues that we have to address in protecting our forest. Key point 3, sustainable forest management. And I'm gonna have to go through these fairly quickly. We have different silviculture systems. And what is silviculture? Agriculture is taking care of agricultural plants. food plants. Mostly silviculture is managing trees. It's growing and cultivation of trees. If you want a lengthier description of it, it's the practice of controlling the growth, composition, structure, we talked about, structure, and quality of forest to meet values and needs, specifically timber production, silviculture. Um, when I worked for the paper company and we were managing land, I was a silvicultural forester. There's systems, there are more than these four, but this will give you an idea. Clear cutting is an even aged, as we talked about, is an even age stand. You go in and you harvest all at one time, hopefully a limited number of acres. Plant it and seed it back and repeat. Clear cutting. As long as you're following the best management practices that protect our water, and there is a book on that that's available online on our website. There's nothing wrong with clear cutting. It's the most efficient way to produce the wood fiber that we need. Um, if you got a family farm, though, you may want to consider the seed tree method, where you take out the majority of the trees, but you leave your best trees standing to provide seed. If you say, well, no, I want more, I don't want to leave my best trees out there, then you can go with shelter wood, where you go in, you manage to produce two different ages that grow in the same stand at the same time. And then once the younger stand reaches a certain age of maturity, then you go in and take off the overstory. You have to be careful on that one that you don't get your density too thick. If your density, if you have too many trees in too tight an area, particularly loblolly pine, that's where the southern pine beetle is probably the second natural um, factor of killing our trees in Alabama. And we're in kind of a lull. It tends to have a sine wave, meaning that it goes up and down the amount of beetles we have out there and the amount of damage they do. The last of the silvicultural systems is selection. And that's where you would go in and a forester looks at each tree and says, this one's ready to go. I'm going to keep this one because it's growing pretty good. And I'm going to take this one because I need, some poles. But you're taking individual trees. And again, silvicultural systems, there's entire books on that. If you want to learn about more of those, um, read one of the books, come get a forestry degree. In silviculture, what do we do to manage our trees? Of course, planting is the number one. We want to make sure that we reforest the areas that we're harvesting timber out of. And like I say, Alabama does a great job of this. We're growing more wood, more trees than we're cutting down. You can also use coppice regeneration, particularly out west where they've got aspen and north. Um, they have other, particularly hardwood trees that are prolific sprouters. And so you allow the stems to sprout. And the advantage of that is the root system is mostly unaffected. So they tend to grow very quickly. It's a great way of producing biomass. There are different types of weeding, just like you weed your garden. We can use herbicides, chemical spray to take care of weed species, either young trees, herbaceous release, or at age 7 to 10, we can go in and do a woody release when we're trying to take the sweet gum that's competing with our loblolly pine if we want loblolly pine for making strong paper. So weeding is important. Thinning, you can go in for our loblolly pine. Once you reach a certain size, we'll talk about basal area, and if the basal area of 120 square feet per acre, once it reaches that, it tends to be what we used to call the term beetle bait. They're competing so much with each other. When the beetles come in, they don't have any energy to fight it off. So thinning is important. It also helps you produce more higher value products. Thinning does not increase the number of tons that you're going to produce on a year over the years on a given acre. but it can dramatically increase the number of dollars that you see. So private landowners, you should be thinking about that. And sometimes we do, and that's a commercial thing that I'm describing, where you're going in to take out trees and to concentrate your growth on your most valuable stems, both valuable species. Um, but there's also pre-commercial thinning. And pre-commercial thinning is where you go in and you have too many stems. In Alabama, most people want somewhere between a 600 and 1,000 loblolly pines on their acre. If you go into one place and you used seeding or natural regeneration and you've got 3,000, you'll need to go in there and pre-commercially thin those out. Pre-commercial meaning you have to pay money, you don't get any money back from it. Prescribed burning, use of fire. They used to call it control burning. Matter of fact, this slide, and I need to make a correction there. They had control burning still on it, but I like to say once you drop a match on a given day, the only person in control is God. What we're doing is prescribed burning. We're choosing and planning the best time to burn, and it's called hazard reduction burning because if you burn frequently, they're low intensity fires. They don't burn up the soil. They don't destroy the wildlife like you see out west. So you do it frequently for that reason. And of course, harvest is the last of our silvicultural treatments. You choose when and how you're going to take the trees out. There are a lot of other forest health and management issues. We talked about biodiversity and forest fragmentation, invasive species, air quality, aesthetics, uh, fire, both wildfire and prescribed fire, climate change, recreation goes on with aesthetics. You'd like to be able to do as much with your land as possible. When I was in high school, multiple use was the buzz phrase, and we still follow that. In other words, our national forest and public lands, we don't own them just to produce timber. I mean, that's why the national forest was created. Um, in the time of war, you use a lot of timber and wood. We still do, but when it started, really used a lot of wood. And so you had the national forest as a safety net, a bank of that. As we've developed and moved on, we found out you can provide that safety net of wood use, but you can also take care of wildlife, do recreation, and a lot of different factors in multiple use. Forest measurements. Um, the first thing we measure as foresters is land, and that is primarily done through high technology, remote sensing, looking at satellites. We now have GIS, Geographic Information Systems, that use GPS, which is Global Positioning Systems, put data in, and we can get very good estimates on land remotely without setting foot on it. We also, surveyors use total station units. Those that have a laser that shoot out 2 miles and measure within fractions of an inch. But we still rely on some of the tried and true, not necessarily for determining area, how many acres, what is the area of our land, but we still use it when we're in the woods to figure out how far we've gone. And that is, we use a chain, 66 feet, which seems odd. Why would you choose 66 feet? Well, if you look at 66 feet and you were to measure 66, a square, picture a square in your mind, 66 feet square, and you'll multiply 66 by 66, you'll see that it's a fraction of the number where look on the screen where it says acres. It's 435.6 square feet when you multiply 66 by 66, or it's a tenth of an acre. It's also an 80th of a mile. And for those reasons, that's a surveyor's chain, is what we call it. 66 feet is a chain. And the way we do it with pacing, we'll pull out 66 feet and we'll pace. And by the way, I see people in competition and they'll be putting their feet one behind the other, or they'll count every step they take. Difference in a step and a pace. Typically, I was in band, so I start off on my left foot, and when my right foot hits, that's one pace. Every time my right foot hits, I count again. So you see how that cuts your counting in half, and you can move faster. And you want a natural pace. And I'll go out that 66 feet. Let's say it's my pace is 12 paces. It takes me 12 paces, 24 steps, but 12 paces to go 66 feet. Well, if I'm counting paces and I get to 120 paces, well, mine was 12 paces per chain. I went 120 paces. Well, I've gone 10 chains. And so I can use that when figuring out distances, and we use it in cruising when we're not using the GPS. Now, don't get confused. The engineer's chain, they use 100 feet, and that makes the math a little bit easier. And again, the acre is what we use in America. It's 43,560 square feet, or 10 square chains. When we measure in trees, we look at DBH, that's diameter of breast height, and that is 4.5 feet from the high side of the tree. And we'll measure it with a tape, and Miss Katie is going to show you how we do that here in just a second. Wood measurements, board foot, cubic foot, cords, face cords, cunits, 1,000 board feet. I'll let y'all look those up. But basically, if you think about a board foot, if you'll picture a plank and you cut off exactly 1 foot, and the plank is 12 inches wide, it's 12 by 12, and it's a 1-inch plank, that's 1 board foot. MBF is 1,000, at the bottom is 1,000 of those. And cord isn't used much anymore. We tend to measure more by ton. But it was a stack of wood that was 4 feet by 4 feet by 8 feet. And that was typical of rail cars. And then you've got a rail cord when they just started designing cars for carrying the wood. So there's a lot of different things for how we measure wood, as well as measuring the trees. Well, this is Miss Katie. She's our urban forestry, urban and community forestry partnership coordinator. Sorry, Katie. Katie Wiswall, and she's going to talk to you a little bit about measuring diameter.
Okay. So when you're measuring the diameter of a tree, there's 3 things that you really need to remember to do it correctly. First of all, remember to measure it at the correct height. You always measure diameter of a tree at 4.5 feet above the ground. Now for me, I happen to know that 4.5 feet is right here. And you can certainly do that. Measure from the ground up on your body to where 4.5 feet is, so that you know when you walk up to the tree where the tape needs to be. You can also use a stick and measure it. This stick is a little bit more than 4.5 feet, but I know where I can put it on the tree to measure my tape. Either of those methods work. You also have to remember that if you're on a hill, you always measure from the uphill side of the tree. Thirdly, if you're measuring a leaning tree, or even a straight tree really, you need to make sure that the tape is perpendicular to the tree, not slanted one way or the other, because that will affect the accuracy of the measurement. So let's measure this tree. So we measure a tree with a specialized tape called the diameter tape. You can actually use a normal tape. This tape has inches, it has feet and tenths on one side, just like a regular measuring tape. But on the other side, it has inches of diameter. Those are inches, but they're bigger than regular inches because they've already done the math for you with this tape. You can always measure diameter with a regular tape, but if you do that, you have to remember that you're measuring the circumference. So to get diameter, you take the measurement from your regular tape and divide by pi, 3.14. We're going to use the diameter tape, so we don't have to do the math. So we get the tape around the tree at the correct height, and then we make sure that it's straight. Once it's straight, then we read the tape. There's a 0 marker on my diameter tape, and you read the mark above the zero. In this case, we're halfway between 16 and 17. So we have a 16.5-inch tree.
Okay.
Okay, so that's diameter, and most of the time we're looking at wood, we're looking at volume. And if you remember, to get volume of a cylinder, it's diameter squared times height. So we need to know the height. This is a diagram that shows how we can use either a Biltmore stick or a clinometer, which is a device that already again has the math taken out, the geometry. But this illustrates how we have how we use the clinometer and other areas other devices to figure out what the height is. Notice we're using right triangles. So we shoot out level, and then we look at the top of the tree. That's the hypotenuse of the right triangle. And notice, if you remember, you have to know what the angle is and with the adjacent length. And that's how far out we pull with our tape. So we know that one. We know the angle, so we can tell you what the height of the tree is. But notice that it says eye at the bottom of the ground. Well, no, he's standing out whatever his height is. And sometimes you may be higher or lower than the tree. You always have to shoot the bottom of the tree. And typically it's like this, your eye is above the stump. And so you'll add that little piece. If you're on level ground, it'll be whatever height your eye is at, 5.5 feet. But if you happen to be looking uphill, when you look level, you're looking in dirt. So you have to remember to subtract that. That's generally how we use the clinometer. When we're cruising, we can measure trees. Again, d squared times height for each tree, the volume, we add it all up. And if we're measuring a 10th acre plot, we add all those together, and that's used to figure out how much wood is actually on the forest. A guy named Bitterlich, Dr. Bitterlich, found out that you could be more efficient by figuring out you spend more of your time on the bigger, more valuable trees. And so he found out that by using a prism, you could calculate not only the basal area. He can take this glass, and if you'll see in the picture, the stem of the tree is so far away from what you see above and below the prism, they don't touch. So we wouldn't count that one. If they we would count them. And you have to dance around the prism because it's the center of the prism that gives you that angle. So you dance around the prism, count those where the picture in the prism and the picture outside the prism touch. And if you get 7 trees and it's a 10 factor, because it can be different basal area factors, a 10 factor prism, you count 6 trees, then 6 times 10, 60, you have 60 square feet of basal area. Now, what if you'd had 13 trees? Again, 10 basal area factor prism, 13 times 10 is 130. Now we're worried about beetles, right? Because anything over 120 can cause beetles. Now, if you're looking at individual trees, that's what this formula is. The basal area, what is basal area? If I was on a flat piece of land and I had all the trees and I had a super laser and I came through and I cut all the trees off at 4.5 feet high and then measured the area of each stump, looking down on it, it's a circle roughly, and I figured out what the area was and added it all up on this acre, which is 43,560 square feet, I'll get a number, and it'll be like 80, 100 square feet, just a small fraction of the 43,000. But for each of those small circles, there's a huge canopy above your head, right? But that's how we determine density, how many trees. We like to decide how many trees out there based on basal area, not just a count. Because, 50 trees may be too little when we initially planted the stand, but if you've got mature oak, 50 may be just right. Same thing with different numbers. So what you're really looking at is density, and for that we measure basal area. Key point 4, trees are an important renewable resource. They definitely are. I've got you a handout on that because I'm running out of time. We have a lot of different products. This is the handout that you're looking for, the first page of it. There are 23 values for those. We have a lot of different ecosystem services, and those are environmental benefits, real dollars that trees provide for us every day that they're alive, and sometimes when they're dead, as far as sequestering carbon, holding that. But stormwater retention, it reduces the amount of water that flows or flushes in pollutions into our stream. The shading can cool for the heat island, reducing that. The trees routinely capture particulate matter out of the air, and they clean our water. I did want to mention iTree software, and you may want to write down itreetools.org. That's one, if you want to see the value of an individual tree in your yard, they have different modules. That would be the My Tree. You can determine what is your percent canopy of your campus, where you're going to high school. But look at those itreetools.org. They've got everything else. The flagship is Eco, iTree Eco. But right now, if I were going to start with it, I would start with something simple like My Trees or Canopy. That said, there's some additional resources. This information, don't worry about copying it down. It's in the last page of the handout. But I do want to encourage everybody to look at that, even though I've talked quickly and I've been talking now for 51 minutes. I haven't covered a fraction of it, but hopefully this will help you be prepared for the test and have some information. If you need to talk to me, there's my phone number. And yeah, that's a tough tree right there. And I'll sign off with my buzz phrase, which is check your trees, please, which means that everybody, all landowners should be looking at their trees at least twice a year. With that, I bid you adieu. Thank you.